That was, the time when there was energy crisis. It started with that oil energy embargo of 73, 74. And now recently you are also seeing, because of Iran, Israel and US war, similar situation is arising, There are a lot of oil crisis, oil prices may jump $100. At that time, the oil prices had jumped almost, I think, 30 times, 300 times. And those are around $30 per barrel. And there was a Nayodhma committee, and they established National Center for Energy Studies at IIT Delhi, and they started research work on solar energy, plasma, then this IC engine, mechanical engineers, and then, electrical energy systems. And we, chemical engineer, chemists, we were working on liquefaction of coal, converting coal into oil. Now you see, let me start with, energy scenario, can I have the next first slide? You see, India is really undergoing a massive transformation. So we, as far as India is concerned, we are very poor in energy. We don't have oil. We are importing almost 85% of our requirement of oil. And then we do not have gas. We are importing almost 50% of our gas. And you have seen that we have been importing oil from Russia, and US has been bullying us on that. Now at that time, similar situation was there, and we were asked to convert coal into oil. And we thought, we had Professor Sarkar there, he was in chemical engineering department, and he said, let us convert coal into oil under ambient pressure conditions. That was not a joke, He said industrial operations under ambient pressure conditions are very convenient. So we should do it all under atmospheric pressure conditions. So we started work on that, and later on we extended work on biomass and other areas. Now coming back to India's energy scenario, you see, in India we have only one energy source, and that is coal. We have, I think, 10% of coal. We are, I think, 5th in the world as far as coal is concerned. Geological Survey of India keeps on discovering new reserves. When I joined IIT, it was 90 billion tons. Today it is 400 billion tons of coal. But we have coal, nature has given us coal, but our coal is of very bad quality. It contains ash starting from 10% to as high as 50%. I remember, my student used to work on coal, do PhDs on coal, and we used to get coal from Badarpur thermal power stations or other thermal power stations from India. And its ash content used to be 42%, 34%. Very high ash content coal. What do you do with that, The coal containing just 60% organic matter, and you have to convert that into oil. And then, oil prices came down. So the oil prices became $18 per barrel. And then, we were at loss. What do we do now? Because coal has become unimportant now. Energy is unimportant. So then we saw that as Indian coal, that is having high ash. But another problem is the ash content in Indian coal, that is inorganic mineral matter, which is non-combustible, that is finely dispersed in coal. Well, in coals, western coals and other coals, the inorganic matter is separate and organic matter is separate. So you can wash them with water and remove. But it is very difficult, organic matter is finely dispersed. So it is difficult to wash the Indian coals and get real clean coal with having less ash. So we thought of starting work on that. Now you see, the thing is that there is a lot of pressure of greenhouse gas emission, global warming and all that. So in the world, coal is a major fuel for power generation. You are mechanical engineers, you may be knowing. We burn the coal through entrained bed firing, pulverized fuel firing in thermal power stations. So here you see the thing is that now there is a lot of pressure to phase out coal. Now we have only one source, fossil fuel, that is coal, and that also we have to phase out. So they are talking of having solar energy, wind energy. These energy sources, I would not dwell much time. I am a coal man, so I am not really very confident or very, what you can say, very happy with the solar and other things, because I know the problems. We are earlier importing oil, now we are importing solar cells from China. Then we are doping those with phosphorus and boron and using them for generating power, and we are saying 50% power is coming from 250 megawatt is coming from solar. But then after 15 years, 20 years, solar cells, you are putting so many solar cells, so much land is being occupied. So where do you dispose of these solar cells? In DST, I am member of one of the committee, which is looking after recycling. I only started that, how to recycle the solar cells. So we have sanctioned around 10 projects on that, and IITs and other universities are working on that. So, solar and wind energy, this depends upon the weather, on the nature. So whenever the weather is not good, moreover, this energy which you are getting today, 70% is coming from burning coal only. Solar installation is there, but generation is very less. Anyway, let me now concentrate on coal. So now, Atmanirbhar Bharat, they want to go on to net zero emissions by 2070. So as of 2025-26, India is the third largest consumer of energy, and we are third largest producer of electricity also. Next slide. So I have already discussed this. Can we have next slide, please? So the India is the third largest consumer of oil, and we are vulnerable to global price. Now we are at the same situation. Yesterday I was watching, in Pakistan there is no electricity after 8 o'clock. Fortunately, we have Modi ji, so we are happy. We are having all these, we are still not affected. But there's going to be a lot of problem because of the oil shortage. So can we have next slide, please, now? India is the second largest producer of coal in the world after China. Earlier we used to mine 250 million tons of coal. Today we are mining 1 billion ton of coal. You can imagine, we are burning 1 billion ton of coal, how much fly ash we are generating, and that fly ash has to be utilized. That is also one of the major problems. It has to be used in cement plants and for brick making and other things also, So the 50% of installed power capacity is solar energy based, but most of, as I told you, 70% energy, electricity is coming from coal only, burning coal only. Next. Next, can I have the next slide, please? Well, you see, the government of India, there is a lot of now pressure. They want to shift from coal to solar, wind, and other things. But we have large reserves of coal. What to do with those? So they want to convert coal into chemicals, and one route is gasification of coal. Gasification means you are basically doing partial combustion of coal. You are burning the coal in presence of carbon dioxide and steam, and you are generating synthesis gas, and from that you can get urea, you can get methanol, you can get other petrochemicals from there, So there is also a thrust on burning, biomass or basically biomass char with coal. Well, you see, I am a chairman of one of the committees in DST where we have sanctioned 9 projects on co-firing of coal with stubble and with the agro residues. In Delhi and NCR, we are having a lot of problem, all of AQI, especially during winter season, when AQI becomes almost 500. So there if you can, there is a lot of pressure from the government that you use biomass char along with coal in pulverized. As a mechanical engineer, you can well imagine, where the coal is being burnt through pulverized fuel firing in the entrained bed, and to use the very less dense char with biomass, how difficult it is. But anyway, I had attended that industrial meet at Thapar University, Patiala on March 6th, and a lot of NTPC and other people were there, they claimed that they are using 7% char with the coal through the pulverized fuel firing, and I'm very happy about that. But I discussed with them, I gave some suggestions to them. Can we have next slide, please? Well, that is to show you coal-based power generation options to use biomass co-firing. Next. Okay, well, government has, producer-linked incentives, so it is promoting the coal gasification, As far as gasification of coal is concerned, as I told you that Indian coal is having high ash. So in situ ash content in Indian coal is 35%. So it is not a joke to gasify, partially burn this coal. We had 3 coal gasification plants, Talcher, Ramagundam at Naveli Lignite Corporation, and we were using entrained, bed, process, copper storage. And those were, for fertilizer plants, fertilizer plants were based on that. And those plants almost failed, and those have been stopped. But now the interest has revived in setting up coal gasification again, The Coal India Limited has signed memorandum of understanding with BHEL, GAIL, IOCL. BHEL has plants on fluidized bed, fluidized bed gasification of coal. They had a pilot plant. EIL also had a pilot plant. So Simfer, they had several plants, So there is, I think ministry, they had invited me to give a lecture. So I told them, we have to do research on Indian coals, and we should do R&D. We should, sponsor projects to IITs and universities so that, some research is done. How to gasify Indian coal having such a high ash content, and which process will suit, whether fixed bed or entrained bed or fluidized bed, which process would suit. But now they were not very happy with my talk at that time, Anyway, the government wants to go ahead with that, They have sanctioned 8,500 crores to promote coal and lignite gasification. Next slide, please. So there was Niti Aayog had organized a workshop on coal gasification technologies for high ash coal content on September 2nd, 2025, chaired by Dr. V.K. Saswat, is a planning commission member. The workshop focused on achieving 100 million tons per annum coal gasification target by 2030. So that is aimed at reducing dependency on the chemicals. We are importing urea also, So maybe methanol can be manufactured if you have carbon monoxide and hydrogen through gasification of coal. Well, the workshop brought together, people from IIT Delhi, BHEL, GAIL, Simfer, and CSIR and Dastur Energy to accelerate the commercialization of gasification of coal. Next slide. Well, that is gasification of high ash Indian coals through fluidized bed process. Next. Well, rationale to the shift is obvious. There is a big environment benefit. You get rid of CO2 emissions, And then, self-reliance, Atmanirbhar Bharat, we are importing oil and chemicals. We can have our own fertilizers, synthesis gas, may be used to prepare polymeric materials, maybe methanol, which can be used in the IC engines along as a along with gasoline. Next. Okay, you see, what I feel is that, we can continue to use coal if we can sequester and capture, the CO2 and utilize CO2 for value-added uses. So we have extended some research at IIT, and a lot of research has been done. In fact, there is a lot of funding, on that, around US dollar $5 billion in 2024, and this will become almost $12 billion in 2023, according to IEA. So there is a lot of work going on, and there are a lot of successes which have been reported, and there are pilot demonstrations by BHEL, SIMFER, and at IIT Delhi. Next slide. Well, that is, there are several plants, where they capture, CO2 and utilize CO2. Next. Okay, CO technologies may allow, continued use of coal. That can be very good for India. We can even have IGCC power generation, integrated gasification, combined cycle power generation, where capture of CO2 is very convenient and very easy. Well, Indian government has committed 20,000 crore towards this in the current budget, 2026-27. So, coal CO2 utilization contributes to sustainability by reducing the greenhouse gas emission. That is understandable, and replacing fossil fuel chemicals with CO2-based alternatives, and that may enable circular carbon economy. Next. Well, future-proofing coal assets, renewable energy penetration will grow, diversifying non-fuel uses of CO2, and the future outlook, despite this shift, coal will remain a critical energy source, though by 2070, it is planned that, it will come down to 161 million tons per annum, but I doubt, as far as India is concerned, we have only coal. We are going for ultra supercritical boilers, and where, CO2 emissions are less. So, more and more, mines are being, auctioned. So, more and more thermal power stations would be set up. So, I doubt it, but I am a coal man, you can take it with a pinch of salt. Next. Well, you see, we worked on coal at IIT Delhi, and we worked for almost 42 years. So we worked on almost every aspect of coal. We worked on converting coal into oil. We did it through solvent extraction, followed by, hydrogenation of the solvent extract to get petroleum-like fuels. Then we worked on gasification of coal. We even used CO2. We used steam. We got synthesis gas. And then we have done some work on carbonization of coal, that is pyrolysis of coal, which is nothing but heating the coal in the absence of air in inert atmosphere. There we get coal tar and other coal gas, and then we get some char also. Then we have worked on refining the coal, organo refining, inorgano refining, and we worked on other clean coal technology like biodesulfurization, chemical desulfurization of coal. India is very fortunate. We have only 0.6% or 0.5%, 5%, not 0.5, 5 to 6% sulfur in our coal, whereas Western coals, they have high sulfur. But our lignites, these contain almost from 5 to as high as 10%. Assam coal, which is a good quality coal, the ash is around 5 to 10%, but the sulfur contents are maybe as high as from 5 to 10% even. We have worked on Assam coal also. Then we have tried to convert, coal into graphite through graphitization, and then we have also converted coal into carbon nanomaterials such as graphene and multi-walled and single-walled carbon nanotubes and other carbon materials. Then we have used those graphene and carbon nanomaterials for producing the carbon-based nanocomposites, which will have better conductivity, better EMI shielding properties, and better thermal conductivity, electrical conductivity, and mechanical strength. Next. Well, you see, that is, I've already discussed how we had started our research. Then ultimately, when oil prices became very cheap, we thought of concentrating our research on refining the coal to get low ash coal and improving the washability characteristics of coal, which we thought of by doing through organorefining. That is because you see coal contains organic matter, it contains inorganic ash, inorganic mineral matter. So if you can use some solvent which can dissolve, extract out the organic matter, then what will be left behind will be inorganic matter. So you can use that organic matter with less ash and prepare chemicals. The other was inorganic leaching. That means that you use alkali or acid, remove inorganic matter and leave the organic matter behind. So we worked on both the parallel approaches. Next slide, please. Well, that was not an easy, task, because the extractability of coal in common organic solvent listed by me here, DMSO, chloroform, benzene, heptane, etc., is not more than 15 to 20%. But that much solubility will not do, So we thought of using different techniques. We thought of using coal-derived chemicals to cut down the cost. We used anthracene oil, quinoline, and liquid paraffin in succession, stepwise extraction, And then we use anthracene oil, ethylene diamine, and liquid paraffin through successive extraction techniques. And we were able to get 50% coal extract. Then later on we used even morpholine and other solvent to remove sulfur from lignites and Indian coals, and we were quite successful in that. We published papers. Next slide. Well, you see, then we use binary two solvents, an N-methyl pyrrolidone followed by ethylene diamine, anthracene oil followed by N-methyl pyrrolidone, anthracene oil followed by liquid paraffin, and we worked on two binary two solvent systems, and we could get extraction yield up to 25 to 30%, which was also not good. But then we thought of doing some other trick. We thought of, working on the physical chemistry of coal, how to break the weak linkages, physical attractions in coal. So we thought of using the solvent which can break these physical attractive forces like covalent forces, So we thought of using N-methyl pyrrolidone as a main solvent, which is used in refineries, petroleum refineries, is a well-known solvent. And we thought of breaking these weak bonds by using ethylene diamine. Or we use monoethanolamine, and we were very successful. We got more than 50% yield of clean coal. We called it super clean coal because it has very less ash. The ash contents varied from 0 to 2%. So we published that paper, and there was a lot of issue and cry in India. People said that it is something very very unusual. How can you have zero ash coal? So a lot of discussions went on in CSIR, SIMFER, and in DST. They gave us project. We proved that yes, coal can have zero ash also. So in fact, coal had 0 to 2% ash. Next slide. Well, you see, we thought of using that super clean coal for getting graphene and carbon nanotubes. So we collaborated with NPL, and we used DC-arc discharge technique to convert this super clean coal into graphene and carbon nanotubes. So then parallel studies were also, we were getting the 80% removal of ash by using alkali followed by acid, NaOH followed by sulfuric acid leaching of coal. And those also coals were used for getting the carbon nanotubes and graphene. Next. Well, you see this laboratory we used to work on. Next. Well, you see, we published that paper, after seeing our paper, people from Tata Steel, they came to my lab. They told me, you have published that coal contains 0 to 2% ash, whereas they were pioneers in washing coals. They said, as far as we are concerned, we can't go beyond 20% ash coal. So I told them, yes, this is possible, Then they sent their engineer to my lab. So we actually transferred that technology to Tata Steel. They set up a pilot plant at Kolkata. We filed several patents, including we filed, US patents, and they set up this pilot plant. They set up another plant at Visakhapatnam based on inorganic leaching of coal. So as I think Professor Subhash Sharma will agree with me, as far as IIT is concerned, there is a lot of thrust on patenting and a lot of thrust on technology transfer. Professor Nigam used to, pester us how many technologies you have transferred to industry. However, very happy, to work with Tata Steel and transfer this technology to them. They have a mine, which contains 21% ash, and they use coking coal for their steel plants. With my technology, they can happily, do that. But unfortunately, this is not economical at present. So importing coking coal is cheaper for them. But then they have this technology with them. Next slide. Well, you see, we have also converted carbon dioxide into graphene by using magnesium ribbon and by using the nickel as a promoter. And we use those graphenes for preparing polycarbonate nanocomposites, and which had good, conducting properties, thermal conductivity, electrical conductivity, and mechanical strength, and EMI shielding properties. Next slide. I will not, I don't have much time now. Next. Well, you see, we also, did some work on adding multi-walled carbon nanotubes into this polycarbonate polymers, and then we were able to improve its ballistic properties. So you can have the bulletproof jackets. So we did this work in mechanical engineering department at IIT Delhi in Professor Naresh Bhatnagar's lab. Next. Well, that's the detail how we did it. Then we improved the ballistic properties. Next. In conclusion, I would say that we were able to clean the coal, and we were able to transfer the technology to Tata Steel, and they have set up a pilot plant. Then we were able to convert the coal into carbon nanotubes, into the multi-walled carbon nanotubes, into the graphene, and use those for preparing nanocomposites, which are very useful in the industries, Next. We also could improve the ballistic properties of these. Next. Thank you very much. I'll be very glad to answer your questions.
Thank you, sir, for that insightful session.
We would now like to invite Professor Sandhya Dikshit, Professor Rajiv Kumar, and Professor O.P. Mishra to honor Professor D.K. Sharma. Thank you once again, sir. Our next speaker is Professor Subhash Sharma, IIT Delhi MTech, PhD in Tribology and Senior Faculty at Central Queensland University, Australia. He uses oil analysis and vibration monitoring to solve maintenance challenges.
Sir, we request you to kindly come to the podium and enlighten us.
Okay, good afternoon, everyone. And Dr. D.K. Sharma, he made me to feel as if I'm really attending an international conference. Earlier, I was thinking that I'm going to attend a Desi conference, you know. But when people say that Subhash Sharma from Australia, I really feel like I'm attending an international conference. So that's my pleasure and that's my really good fortune to be with you. I'm not going to talk anything formal because my slides are not in order. You know, I put one thing or the other and I couldn't have access to internet, you know, when I wanted. So please, next. I'll give you a brief introduction where I'm from. So I'm from okay, well, that sounds good. So I'm from Central Queensland University. This is a regional university that has got 26 centers, you know, or the campuses. And there are 2 international campuses at the moment. And especially, you know, the course that I was heading, not now, I was stepped down. So that is, you know, is a asset and maintenance management program. As a mechanical engineer, you might have noticed, you know, there are heat, thermal, production engineering, manufacturing engineering, and so on and so forth. But this asset or maintenance management course evolved on a demand from industry, direct demand from industry. And this direct demand from industry, that was that we want to train our engineers. So that is Queensland Alumina Limited. Those people, they approached us and they said, we want to give training to our staff and make them you know, maintenance experts. So that is how it started. But in 2014, when ISO standard has come in the market, ISO 55000, 55001 and 55002. So when those have come into the market, then I was given this responsibility to develop a course that is based on asset management rather than maintenance management. And maintenance is the subset of a maintenance engineering, whereas maintenance itself is a subset of mechanical engineering. Please, next. We have got around 32,000 students, and at the moment we have 16 campuses because 10 campuses have been either merged or shut down. And these people, you know, they are, most of the teaching is via long distance, you know, or the online. And then, so this is Australia. And over here, as you could see, that there are so many campuses. Along with that, there is campus in Indonesia. Earlier it was in Singapore also. And recently we had a collaboration with Kuwait, so we have that is a research collaboration. We give, because I belong to asset and maintenance management, so graduate certificate, graduate diploma, masters and PhD, these are the degrees that we give, and we have got about 400 students altogether. So what to teach under this is the procurement, operation, maintenance and disposal. Any item or entity or a thing, it has been written in the definition like that. Anything or entity that has a value, that is an asset. Like Dr. Sharma was saying, the ash, fly ash that is coming out. If it has got a value, that is an asset. Okay. So you have to extract that value. You have to realize that value out of the product or the asset. So that is the purpose, of this engineering. And as a mechanical engineer, any industry that is asset intensive, so that is where our main focus is. Say, for example, 2600 BC, people had these carts in Egypt. So that means it shows that people had those manufacturing capabilities. And if they had manufacturing capabilities, they too had a concept, maybe a vague concept of rolling motion, because there are wheels and there is an axle. So if that is there, likelihood that by that time people might have developed a lubricant as well. Though evidence of lubricant in Egypt, that comes a lot later, not in 2600, but maybe 1500 BC or something like that, that people used to use a lard oil to transport big structures. So the lubrication concept, was not well understood, but it was there, Now we talk about the modern assets. Modern assets, say for example, Airbus 380, each Airbus has got around 4 million individual components. If you see their inventory, so inventory has got about 4 million individual components by which this aircraft is built. And 25 million parts, numbers produced by 1,500 companies from 30 countries around the world. And 19,000 bolts are inserted inside the fuselage to attach each of the 3 main parts, and plus 4,000 to attach both wings. So now you could imagine, that what kind of number of small items. So each item that has a value, that is your asset, and you have to maintain that. Over here, you people might have heard, that any industry you go, so top boss, okay, then there is a department, and the department is human resource department, okay. There may be power generation or accounts and this and that, and then there is a human resource, HR department. So HR department that handles human beings, their induction, their training, their retirement, all those things. But if I don't know if you have seen or not, any industry, they don't have similar in the parallel, ground, any asset department like HR department. And that is what is happening now, that people are realizing that like human beings are being managed, we should manage the assets as well, So that used to be. Now, a simple thing, like in the morning I said, the plan, do, check, act. Here the plan, acquire, operate, maintain and dispose. Any entity or any asset that you have passes through these stages. You have to plan whether you want to procure, whether you want to hire, whether you want to build, whatever you want to do. and then you acquire that, After acquiring, you use it. So when you are using this asset, that may be a machine, that may be a computer, that may be a table, whatever it is, So during that uses, that is when you need maintenance. Okay. So maintenance, and then when its life is over, we will say, that why life is over. Basically, it should never be over. But when, due to normal wear and tear, the components, they don't perform the function for which they have been designed, then you call it is failed. And if you repair it, if it is beyond the cost effectivity, then you dispose it off. Okay. And disposal, that means a responsible disposal, not like batteries, you put it in the normal dustbin. Okay. So that is called the asset life cycle. Anything that reduces life cycle costs, that is asset management principles, asset management leadership, risk management, data management, continuous improvement, reliability, health and safety, asset management tools, environment standards. So all these things, they are associated with those machines with whom you will be working if you are working in an industry. Okay. And when you deal with this, so anything that reduces the life cycle cost, it's not like that you have dug out the lithium, okay, and then you have made the battery, and in order to take out, say, 10 grams of lithium, you might excavated, say, 20 tons of earth, yeah, and then, you have spent more energy in excavating rather than, getting out of the 10 gram of lithium. I'm just giving you an example. So when you talk about the total life cycle cost, that means starting from, planning up to the disposal, that's the cost associated that you should take into account. Same as like, if gas, someone says with the gas, I will make electricity, and from electricity, I will cook food. Why? If you can make food directly with the gas, then why to produce electricity first and then do it? That's not an effective uses of asset. Now, tribology as such, how many of you have heard about tribology or studied? Can you raise your hand? Not. Okay. So only few people. I'll just briefly introduce you. So tribology is nothing but lubrication, wear and friction. And as I said, any machine that is called machine, that means it has got a rotating or sliding or rotating, sliding, combined parts, those who are in relative motion. So anywhere that parts are in relative motion, that you call it a machine, otherwise you call it a structure. This hall, walls and the roof, this is a structure, but if there is anything that has got a motion and which is a relative motion, that is a machine. Okay. So over there, tribology as such, study of wear, friction and lubrication. So these are the things, that we are going to a maintenance professional with. Here I want to say that when you are working in an industry, so in the industry, anybody who is a maintenance engineer, okay, you can become a good maintenance engineer if you are clear about the fundamentals of lubrication, friction and wear. If not, and you are just doing repair, that means you are not doing a responsible job, okay? And you are just like a technician. I might give you an example. I did some consulting job, and they say my bearings are failing. When it's a cotton industry, I said, are you giving enough oil? They showed me a person is giving oil, and oil is overflowing. But the thing is, where the oil should go, those are clogged, and he is putting oil everywhere. So, if it is not at the right place, that means it's not a right practice, So, So that means unless you have a good knowledge of tribology, you cannot a good maintenance engineer. Similarly, about assets, when you are a maintenance manager, so you are buying a machine, you are an engineer, you may be a production person, but decision is made by whom? By the accountants. They tell that you have to buy the cheapest machine. And the operation people, operator, he wants the best machine, no matter what the cost is. And maintenance person who is responsible for maintaining that, he has no say. So now this concept has come since 2014. It is rather since earlier. It is taking place, that there should be asset management department, and asset management people who has training in maintenance and tribology, they should make decisions and in consultation with accounting people and operators and everyone. So, so here, if you are a maintenance engineer and you do not have knowledge of asset, if you are an asset manager and you do not have knowledge of maintenance, that means you are simply an accountant. Okay. So there is a difference between accountant and asset manager, and there is a difference between an engineer and maintenance engineer who does not know tribology. Okay. So, so as such, like there is a friction and a wear, and then there is a lubrication. So these three things are a must. I should keep a track of time, perhaps just show me give me when there are 5-10 minutes, let me know. Go ahead, please. Next, please. So objective of tribology is basically that to conserve material, conserve energy, and manufacturing efforts. Okay. So by friction, reducing friction, if you reduce friction in, say, ball bearing, how much is the friction? And if I put this much of oil, I have developed a equipment at IIT Delhi to measure the oil film thickness in a ball bearing. So that is up to half of a micron thick. And over there, the friction is hardly 0.001. Okay. So those kind of things, so conservation of material, energy, and manufacturing efforts. The bearing, that you buy for $20, $10, rupees or whatever, but this, what is the cost of the bearing? It's if you 100 gram of steel, which may be $2, but you pay $20 because of the manufacturing costs. So those manufacturing efforts, those are also saved. Okay, please, next. I know that I won't be able to cover the whole thing. Tribology principle as such, that no matter how smooth two surfaces are, they are still rough. Okay. If it is a glass mirror type like surface, it is still like 0.001 micron rough. And with this, so when these asperities, these peaks, when these peaks, they come in contact due to its own load or the weight, what happens? They get fused into each other. And that is phenomena called cold welding. So when you want to move one surface against the other, you have to break this weld, cold weld. Yeah? Pardon? Jaldi kar दूं? चलो जी जल्दी करते हैं. Okay. Anyway, so this is like the energy that you use. This is called frictional energy. So that is how you use. You can't see with the naked eyes, but if the needle, two needles, their points are touching with each other, and they get fused. So that when you try to break them, then that is what is the friction. And if there is a debris coming out, that is wear particle. Okay, so please next. So energy could be spent, the friction energy could be in terms of heat, elastic deformation, noise, sound. So all those things, they are all form of frictional energy. So, okay. How to reduce friction? Reducing friction means that if you could reduce the shear strength of that joint cold weld, that means you have succeeded in reducing that friction. And how to do that? A smart thing is that you use a lubricant. That means you use a third body which has got low shear strength, and that is nothing but a liquid or the lubricant, which is liquid. And shearing those liquid layers is a lot easier. Move forward, please. But the question is, when one surface is touching the other, how to retain that liquid or fluid in between the two? Where the moment you apply pressure, that flows out. Okay. Next, please. So there are three things. If you make it a wedge shape, okay, one surface is straight, the other one is a wedge, and then there is a relative motion. That means it will retain the fluid in a motion. And by doing this, you have developed a new concept of called bearing. So this is called bearing. In a roller bearing or in a sliding bearing, this is what happens. There is one surface taper, and then there is a straight, and in between there is a fluid. So this fluid try to pull this whole liquid, through this small exit, and it creates pressure. And that pressure during relative motion gives you the load bearing capacity. So that is how, even if you apply a lot of load, the oil is going nowhere. That has to flow through that. So that is invention of that. Bearing was used, but the principle was invented or known not many years. In 1986, when Reynolds had used the equation, after that people knew that bearing the principle of hydrodynamic lubrication. Next, please. Anyway, so when bearing is in motion, there are different lubrication regimes. That's what happened. Move forward, please. Move on, please. Move on, please. Next. Yeah. Now, as I said earlier, that if tribology is properly used worldwide, then automakers could reduce inefficiencies up to 61% within 2 decades, and up to 700 billion worldwide could be saved, and burn 102 billion fewer gallons of gasoline per year, and 1 to 2% GDP loss due to wear in the US. That is, GDP is about 16 trillion, and 15 pounds. That is what you could save it, in UK. And they have suggested, VTT, Dr. Holmberg, I met him 20, 30 years ago. So he developed, this data, and rather he is working hard, in this area worldwide, how to reduce the energy. Okay. Energy consumption, as you could see, in various type of industries, that has been shown here. I will not go further in details. Go ahead, please. This is again like in what trucks and buses. There was a time when 0.15, coefficient of friction used to be, but back here in 2025, technologies have been developed, and now it has come to 0.01 as well, in trucks. So that is due to improvising the methods of lubrication. Go ahead. Move on, please. Okay. Now, this morning I was telling you a new tribology research is going on. That is called mimic tribology or mimic biotribology. So key features of biometrical are like surface texture, self-lubrication, adaptive friction, and a multifunctional friction plus corrosion cleaning. These are the things have been learned from the nature, and that is what being adopted now. Go ahead, please. So, and this is being used, in various has got various applications. This morning I told you that wipers are used in the car. If we make coatings, that is, like a lotus leaf, then you don't need wipers, And the technology is already in process, but it's quite expensive. All right, so I think, one more, and then I will. Go ahead, please. Lizard, you know that on the vertical wall, due to the suction, like with the micro cavities, it can climb up. So that adhesion, type of technology needs to be developed, and research is going on. Adhesion control. Okay. So friction control, I told you, like snake can move forward with a low friction, but when it comes back, there is a high friction. So that kind of surfaces need to be developed so that similar things could be used in machines and other applications. This is about snakes, they cannot and unless they move like this, they cannot move forward, So that phenomena has been explained. I don't have time to explain that, but okay, human joints, as you know, that the cartilage that is being synovial fluid that we use between the two bones. So there is a cartilage layer, being used, and that demands a lot of research. The reason being, when we are moving, then it lubricates like a ball bearing, But when I'm standing, still there is no pain. So that phenomena, people are trying to understand more and more, that how by nature you could lubricate a joint when you are not even moving. When you are moving, that is understood well. So I think, since time is not enough, there are so many things, so many standards are coming in ISO standards for asset management. You can go next, please, and lubrication, especially nano additives. Even Dr. Sharma was telling, graphene is used, these days, in very, very common, and using, different type of materials, modifying surfaces, by which we are trying to reduce the friction. So that research is going on. And AI is everywhere, so you can apply wherever you like, and that is being done, especially in maintenance, like you are using drones, to monitor things, and you could do dual imaging, such kind of technologies, and that's how even I'm involved with few projects like that, in Australia. So I think I will not explain the whole thing because the time constraint, but this is, if you have any question, I'm more than happy to answer you. Otherwise, you must be hungry and proceed for food. Quick up.
Thank you, sir. Now we would like to invite Professor Arvind Gupta, Professor Sandhya Dikshit, Professor Rajiv Kumar to honor Professor Subhash Sharma. Our final plenary speaker is Professor Basant Singh Sikarwar.
Postdoctorate from Iowa State University, PhD from IIT Kanpur, MTech from IIT Roorkee. He heads mechanical engineering at Amity University, working on thermal energy storage and bioengineering.
Okay, good. So, thanks for giving an introduction. First, I would like to thanks to organizing team for giving me a chance to present my work in front of you. I'm heading the Department of Mechanical Engineering, Amity University, Noida, since 2015. As my postdoc from Iowa State University, USA. PhD from Indian Institute of Technology, Kanpur, and Masters from Indian Institute of Technology, Roorkee. I have experience in field of thermal and fluid engineering for 15 years. Especially I am focusing on a thermal and fluid engineering, two-phase process and interfacial transport phenomena, focusing on experimental computational studies. So today I am talking about how we have to use the surface engineering for enhance the transport coefficient of the condensation process, and special application for water harvesting from atmospheric air. So people are trying to be different sources of water, but this is one source of water. How we have to condense the water effectively and efficiently, economically. This one?
Both you can use.
Okay. Effectively and efficiently. So, as you see, the title of my talk is Beatability. Something is wrong. Yeah. So, beatability design of metallic surfaces for enhancing the water harvesting from atmospheric air. Next slide. Next slide, please. So, I am just talking about the Amity University. This is one of the private leading university in India, where you have to see that we are a 20-year-old. We have several campuses, India and abroad. In India, we have a campuses in Delhi, that is Noida, Lucknow, Gurgaon, Jaipur, Mumbai, Gwalior, Kolkata, Raipur, Ranchi, Patna, Mohali. Almost most of the state we have a campus, and we have many international campuses here. You can see that Dubai, Abu Dhabi, Singapore, South Africa, Amsterdam, and Singapore. And we run the many courses. You know that in a research, our university index is H index is 204 plus. We have several publications, transfer the many technologies, many book published, and we have many research funded projects like Department Mechanical Engineering still have 5 research funded projects from various funding agencies like BRNS, DST, DRDO, etc. Next slide. These are the facilities I have in my lab. So as I told you, my research is towards the experimental and both computational. So if you see here, we have a CNC micromilling machines, we have laser micromilling machines, we have like a CVD chemical vapor deposition, we have a indigenous goniometers, we have like a high performance computing facilities, like several plasma sputting facilities, so many facilities for especially for altering the morphology of surfaces, as well as we have to do the simulation kind of activities. Next slide. So the content of my talk you can see in these slides. So first I have to give the introduction to condensation. This is a kind of very fundamental like a film bias and drop bias condensation. I am brief about that. Then I am talking about the alter the surface beatability, like a surface morphology, how the effect on the beatability, and how to estimate this surface beatability. Then I'm talking about the fabrication of utility gradient engineered surface. And then we have a surface demonstration of atmosphere water harvesting, device development and conclusion. Next slide. So click next. So as you see that when the vapor come to contact with the surface, which temperature below than to a dew point temperature, so it will be a condense. And there is a two form of condensation. One is a film-based condensation. When the vapor form a film, it is called a film-based condensation. When vapor is condensed in form of drop, small nucleation sites, then this is called a dome-based condensation. Next click. And if you talk about in terms of the transport coefficients, so drop-based condensation, heat transfer coefficient at least 1 order higher than to a film-based condensation if the degree of subcooling is very less. If the degree of subcooling is large, then the drop-based condensation heat transfer is drastically reduced, all these things. So people are thinking to how we have to make a drop-based condensation more effectively, because if the degree of subcooling is very less, you can see that the condensation coefficient is at least 1 order higher than to a film-based condensation. Next slide. So major application of drop-based, especially the condensation, you can see here in these slides. So we have a vast application of the condensation, thermal management of electronics, then we talk about the water harvesting, then we have to talk about the power plant industries, talk about the petrochemical industries, and we have to be like a solar based many water desalination systems, all these things, and water harvesting from fog collection, all these things. So you can say this, the condensation has a vast applications in many industries. Next slide. So film-based condensation, as I told you, form a film on a surface is called a film-based condensation, and this is the known theory, Nusselt theory, which has to be given to measure the heat transfer coefficient. Nusselt theory is based on the, you have to know that the combination of the momentum equations as well as the energy equations, and when we have to be basic do the like energy balance and momentum balance, you get a very simple formula which is given a many fundamental book of heat transfer. Next slide. So here you said next slide. Next. Okay, so this is the average heat transfer coefficient like in a film-based condensation, and many book very well explain about the film-based condensation. Next, drop-based condensation. Next, click it in this video. Click in this video. Yes. Next, go back. Click on this video. So click on yeah. Yes. So you see that this is the condensation on a hydrophobic surface. So water form a special nucleation sites in form of droplet. It is grow by direct condensation, coalescence. Then it is slide off or maybe fall off, depend on the gravity direction, all these things. But when you see in a, it is a kind of a, I'm say that is a continuous process where what we have to be a formation of the droplet at a specific nucleation site. This is called nucleations. Then the growth by direct condensation. Then we have a growth by direct coalescence. Then slide off, again re-expose the surface here, recondensation. That's why it is efficient method, because it is automatically re-expose the surface. It provides the less thermal resistance. Because of the less thermal resistance, one of the, it is condensation rate is very high. So you can see here the drop is coalescence, and there is jumping of droplet is also, that I am not discussed to more detail about the. Next slide. So you familiar about the, so for a drop-based condensation, we need a like a hydrophobic surface, super hydrophobic surface. The ideal surface for drop-based condensation is a super hydrophobic surface, low contact angle hysteresis. So that is a one important things. In nature, most of the metallic surface, like you see the copper and aluminum, they are in a hydrophilic nature. They have a high energy materials. So we have to be alter the morphology of this surface. Next slide. Please, next slide. So, like if you talk about the characterization of surface weighting, so like if you put the water droplet on a surface, it form a contact angle. If this contact angle is less than to a 90 degree, we say that the super hydrophilic surfaces. If the contact angle more than to a 90 degree, then we say that the hydrophobic surfaces. If the contact angle more than to 150 degree, then we say that super hydrophobic surfaces. And contact angle we can find out by the very like a young equations. It is the balance of the three surface energy, like a solid liquid interface energy, liquid vapor interface energy, and solid vapor interface energy. You can see very clearly on these pictures, like a three energy balance is called cos theta. If the theta, as you see in the first photo, when theta is less than 290, we say that the hydrophilic surface, and super hydrophilic surfaces the contact angle less than to 20 degree, kind of these things, and super hydrophobic surface contact angle is more than to 150 degree. Next slide. So like many engineering materials like hydrophilic and super hydrophobic, like a Teflon is one of the material we people are provide the Teflon coating on the metallic surface. It form a hydrophobic when the contact angle greater than to a 90 degree, and a super hydrophobic surface when contact angle more to a 1. For this we have to be treat the like a organic saline coated surface, all these things. So if you see the material which is using for the coatings, like a fluorinated saline method, nanoparticles methods, organic modified silica, organic silica gel, low surface energy material, these are silicons, fluorocarbons, fatty acid, alkyne solution, all these things. So low surface energy are used for enhance the hydrophobicity of metallic surface. But what happening by nature, these all materials are in a low thermal conductivity. So coating thickness optimization is very, very important. If you take the large thickness, then it provide the additional resistance, which is not beneficial for a condensation. If you provide the small thickness, then there is a problem of the leaching, means they have to be leach out, stability issue, or maybe a long term stability issue, kind of these things. So like making a coatings and doing like a super hydrophobic special in a metallic surface is one of the big concern for researchers. Next slide. So nature, if you go in a nature, if you see in this slide, so I am taking the most of the picture from the natures, like a butterfly beings, like you can see that the honeycomb like microstructure on a two-tile leaves. You can see on a somewhere you can see the like a bump, hydrophilic bump. So these are the pictures of the leaf and plants and beetles in a nature, and they are survived because their skin like a hydrophilic. So they attract the water, then hydrophilic water is like a transport the water, kind of these things. So we learn a lot of from the natures, and if you have to be do the like a micro scale analysis on this surface, so this surface is hierarchical surface. What is the mean of hierarchical surface? The order of roughness on this surface is a micro order to nano order. Somewhere micro order, then this nano order roughness is superimposed on a micro order. So this is the kind of a surface nature where you can see that like a lotus leaf, if you put the water drop it is slide very fastly, kind of these things. So this is in nature is a very high super hydrophobic surface as well as a low contact angle stresses. So we have to learn so much things in a nature to be fabricated like a super hydrophobic metallic surfaces. Next slide. So and as I told you, roughness play a very important role. So there is a two state of the drop if sitting on a rough surfaces. One is a benzyl stated, and another is called a Casey stated. And in a both state, benzyl state and Casey state, they are differentiated in terms of the contact angle stresses. If the drop is in a benzyl state in a roughness, and if you have to be increase the surface roughness, then it is become a more and more hydrophilic. If the drop in a Casey state, like a smooth hydrophobic surfaces, and you have to increase the roughness, then it enhances the super hydrophobicity of the surfaces. Apart from this, if there is a benzyl state, it means the droplet is penetrate to the roughness, so it provides the like a large contact angle stresses. So generally in a super hydrophobic surface or hydrophobic surfaces in benzyl state, in drop bias condensation not preferable. Next slide. So here I am just talking to a various type of surfaces, like hydrophobic surfaces, plain hydrophobic surface. Plain hydrophobic surface, like you have to do some smooth coatings, like some coatings of the low surface energy materials. Then you have some coated surface, you have to be like this. Then super hydrophobic surface, Then you have a plane microstructure surface. So in plane microstructure surface, you see that the droplet pentane to a pillars of the microstructure, then this is called a benzyl state. If you have to be see like a hydrophobic coated microstructure surface, if the droplet sitting on a plus, it is not penetrate, then it is called a Casey-Vexus state. Then there is a nanostructure surface, when then hierarchical structure surface, like you have a microstructure, nanostructure, you can see in slides here. Then the liquid infused porous surfaces, you form a porous of the surface, then you have to be put the liquid like a low surface energy liquid like a, then it become a like a liquid infused porous surfaces. So these are the surfaces people are trying to be in a literature, and we also be explore the many methods to fabricate a super hydrophobic surface. As you know that my target is to enhance the transport coefficient of condensation. So I am only focusing on metallic surfaces like a copper and aluminum. These are the two surfaces which is more and more popular for the using in a energy systems, all these things. Next slide. Contact angle, as I talked to so many times about the contact angle stasis. So what is the contact angle stasis? So you can see there is a in this slide. So the dop is sitting on an inclined surfaces. So one parallel component of gravity is acting to the normal to the surface, one to the parallel of surface. Normal to the surface dop is try to be hold the droplet on a surface, parallel to the surface try to move the surfaces. When this is reached to the some incipation of sliding, the leading side contact angle is called the advanced contact angle. However, the tailing side contact angle is called the receding contact angle, and this difference is called the contact angle stasis. Basically, this contact angle stasis is quantified the retention force provided to the hold the droplet on a surfaces. So you can see in these slides, and generally we have to be quantified in terms of the dimensional number, bond number. We say that the bond number is greater than 2 1, then your gravity component is overcome to surface tension force, the droplet will slide. When less than 2 1, then droplet will not be slide, it is hold on a surface like this. And you know that most of the time our interest is how fast drop is slide, how fast, how small size droplet is slide, all these things. And there is one easy method to measure the contact angle. You said that pushing and pulling. You put the drop on a surface and you have to push the water droplet. Then this droplet is grow. Then during the grow, whatever the contact angle is coming, this is called the advanced contact angle. When you have to push the droplet by the micro surge pump, then this is called the receding contact angle. Next slide. So this is the setup. This is the very, I am say that indigenous setup. You know that market there is a very kind of I am say that surfaces. They surface this is the indigenous, and what is the one uniqueness of this setup? It is also measure the dynamic contact angle is also. Most of the, you said that goniometer which is available in market, they have to be a capability to measure the static contact angle and the contact angle stasis. But this setup has a capability or has a uniqueness to measure your dynamic contact angle is also. A dynamic contact angle play a very important role, and we have modeling the droplet sliding in a hydrophobic surfaces. Next slide. So fabrication of hydrophobic surface, I am giving the basic brief about your measurement of contact angle, surface morphology, effect of the surface morphology. Only 2-3 minutes. So all these things. These are the methods and material for fabrications. So we use the physical testing, we use the chemical testing, we use the coatings of low surface energy, all these things. Next slide, please. So these methods, and this is the schematic diagram of all these methods we are generally used in our labs. So we are using the laser evaluations, plasma deposition, plasma etching, chemical vapor deposition, chemical etchings, spray paralysis, dip method, electro deposition, self-assembly, monolayer distribution. Next slide, please. So you can see basically I am interested of the 3 type of surfaces. One is a super hydrophobic surface, low contact angle stasis. Second is a unidirectional wettability gradient. So what is I have a ISRO project where people are trying to be produce the water from the most air in a space applications, space stations, where the most of the humid air of the surrounding environment is available, because they are using the drinking water. Then they have used the many type of unused water, throw this water, then we have to use like a, why we batability gradient? Because drop bias condensation is more effective under the gravity and vertical surfaces, because drop is slided by the gravity. What why in a unidirectional batability gradient, the capillary force, the batability gradient is play the important role to remove the droplet, and one is a, like a pattern surface, pattern surfaces. So like a hydrophobic, hydrophilic, like these are the patterns. Nowadays it's very I'm saying that effective. You know that most of the leaves, all these things. So pattern is like a hydrophilic, hydrophilic. So same principle we are trying to be here like this. Next slide. So these are the methods how can prepare the hydrophobic, super hydrophobic surfaces. So this schematic flow chart is show you the chemical etching by nano etching, then putting like a hot water treatment, then texture by aluminum surface, then chemical modifications, then last we have to be like, this is the very simple process. Next slide. This is the pattern batability surface. This is very unique surfaces. UPSU, our latest publication in International Journal of Heat and Mass Transfer. So this is the pattern batability surface. So we use the plasma etching as well as the masking and use the hot water treatment, chemical etching. So kind of a, then we make a pattern like a hydrophilic, hydrophobic pattern. You can see next. This is the pattern batability surface. So plasma etch surface, contact angle more than to 150. Polished aluminum surface kind of a 80, and hot water treatment is very super hydrophilic kind of a nature, all these things. Next slide. This is the unidirectional, how can make a unidirectional batability gradient surface. So this is a chemical surface. We take the hot water treatment like a texture aluminum surface, and we dip in a solution, ethanol solution, and slowly rise these surfaces so that the gradient is very like this. Next slide. Another method we use like a plasma etching. So what we have to do, we put the surfaces, then we have to expose this surface in a plasma in a different time steps kind of these things. So we create like a batability gradient uniform. Next slide. So this is the experimental setup like lab scale in our department in my lab. Especially we have to be demonstrate the surface performance in a most air condensation, and this surface has a uniqueness. We have to create the environmental conditions like relativity different temperatures or be like this. You know that nowadays is a very hot, relativity is below than to 40, temperature is more than to 30, 37 like this, and this condition is not appropriate. Especially the generating the atmospheric water is a more I'm saying that efficient conditions when there is humid. The relative humidity more than to 60% and temperature is a 32 to 37 kind of activity. So next. These are the patterns, especially this pattern in a super hydrophobic surfaces. This is a vertical orientation, different degree of subcooling. So rate of condensation in liter meter per hour kind of this. And this is like your super hydrophobic downward phase, like condensation here. So droplet grow and slide, and previous one is verticals, and these are the trend of rate of condensation with respect to the relative humidity. Next slide. And this is for a unidirectional batability gradient surface. You can see here. These are the data which is show the rate of condensation on a different kind of a. Next slide. This is the vertical plane super hydrophobic, vertical pattern super hydrophobic surfaces. So you see that the vertical pattern surfaces under the gravity is less effective. But in a horizontal plane hydrophobic surface, horizontal batability gradient, you can see that it is very effective surfaces on these things. Next slide. Next. So can you run? So condensation on a pattern surfaces. Next slide. Next. Click next. This is a condensation of super hydrophobic surface. This is the condensation of previous. Go back. I think this is the interesting for you people. So first is a condensation on a pattern batability surface. So what happening? Especially condensation occurs on a super hydrophobic surface, and hydrophilic work like a passes. So it is remove that kind of. So condensation of super hydrophobic vertical. Can you click on this video? Please click on this video. Next, the middle one. Yes. So what happening? You can see that the condensation, then they are slide off. They are slide off by the gravity. But this is a batability gradient surface, and this is a downward facing. Downward facing like this is a vertical facing. Both are vertical facing like gravity is playing like this. But this is a downward facing. Can you run the last one? Yes. So what happening? This is like a this passage. So drop is grow here and slide towards the your lower weightability to higher weightability sides. So the gravity does not play any role to remove these droplets, and this surface is very very effective in a like a microgravity kind of a conditions. So next slide. Next slide please. So these are the data we have to be develop water generation rate, different air lead condition, specific energy consumption, different air lead conditions. Next slide. Next please. These are the atmosphere water generation schematic diagram layout. Next. These are the different cooling technologies we are using for the generating that one. So we use the loop heat pipes. We people are loop heat pipe and pulsating heat pipe kind of activity for enhance the condensation. Next slide. I think, can you click on this picture? This video, yes, click. So this is the device we developed recently. We already patent, now we are tested in many places. So it has a capacity to generate like a 25 liter per day in a relative humidity like a 85% and temperature is kind of a 32 degrees Celsius. Please next slide. Next slide. Next. So I'm just summarized all these things. So you people have a hungry and you know that lunch is already over. So I don't take too much time for you and I'm very kind of hurry all these things. So maybe if you have any doubt, any kind of confusion or maybe some questions, we are free to talk to you during the lunch hour. So thank you very much. Thank you. And I acknowledge the Science Energy Research Board, SERB, for providing the fund to carry out this work. Thank you.
Thank you, sir.
We would now like to invite Professor Sandhya Dikshit and Professor Rajiv Kumar to honor Professor Basant Singh Sikarwar.
मेरा लैपटॉप होगा.
Thank you everyone. We now request every participant to kindly proceed for lunch at Krishna Bhavan, first floor. All coordinators, please assemble near the stage.